Okay, this is over chapter 10, objective 6, which is motor unit response. So with motor unit response, remember you've got muscle contractions. They can go from strong to weak. They're going to be graded, which means they're going from strong to weak. So you're going to need more force for something heavy than for something light. Your muscles are just going to have to work harder. Now, there's two ways to do that. You've got what's called summation, which is one way that you can make the muscles work harder, or you've got recruitment, which is another way that muscles can work harder. Now, you need to know the definition between summation and recruitment. So with summation, you are increasing the force of the contraction. So basically, you're asking the muscle to work harder. You are stimulating it at a high frequency. Now, with recruitment, you are increasing the number of muscles that are working. So with summation, you're still using the same number of muscles. You're just making them work harder because you're increasing the amount of stimulation that you're putting on the muscle. But with recruitment, you're bringing more and more muscles in to do the job because the stimulus strength is increasing. Summation, the stimulus strength is not increasing. It's the same. So you've got some handouts. This is one of them, I believe. With muscle summation, I want you to take a look at your stimulus. The green arrow means something. Notice they're all the same size, which means the stimulus is the same size. I also want you to notice what we have here is the upswing right here. That is the contraction phase. This right here is the relaxation phase. So if you notice when the stimulus is hitting the muscle, let me kind of change colors here. When the stimulus is hitting the muscle, notice the muscle's not coming to complete relaxation. Complete relaxation is if that was to go all the way down to that x-axis, right, and be 0. This over here on this side should actually be force, right, or how much work is being done by the muscle. So that should be the force over there. And you can see when the muscle is completely relaxed, it'd be at 0 and there'd be no force. However, the stimulus here is hitting the muscle, and the muscle is not able to completely relax before it's being stimulated again. So what you have is the work being done by the muscle is increasing each time, even though the stimulus didn't change. So you're not asking the muscle to do more work. You're not saying, okay, first lift a piece of paper, now lift a 10-pound weight. You're saying lift the same piece of paper over and over and over and over again. And what's going to happen is your muscle is going to ultimately be able to do more work. That's summation. Now, muscle recruitment is when you're actually asking it to do more work. So if you look down here at the stimulus, you can see that the stimulus strength is increasing. First, we have a threshold stimulus. Then we have a submaximal stimulus, then we have the maximal stimulus. So our stimulus strength is increasing. If we come up here and we take a look at our motor units in the top box, we're just going to call this motor unit number 1. We'll call this motor unit number 2, and we'll call this motor unit number 3. Now remember what a motor unit is. A motor unit is a motor neuron, one motor neuron, and all of the muscle cells it's communicating with. So we've got 3 separate motor units in that image. So let's say with a threshold stimulus, we're only going to be using motor unit number 1, okay, because it's just a small stimulus. We don't need a lot of work being done. Now, notice with the second situation, we have a submaximal stimulus. With the submaximal stimulus, we're going to need more motor units responding because we're asking the muscle to do more. So maybe we have, motor unit number 1 and motor unit number 2 involved. Now, with the maximal stimulus, maybe we have all motor units engaged. We've got motor unit number 1, we've got motor unit number 2, and we have motor unit number 3 involved. So again, we're using more motor units because we're asking the muscle to do more each time. You do need to know your definitions. We talked about this back in chapter 12. I want to draw your attention to the little difference in the image up here. In the previous discussion in chapter 12, we had action potential sitting up at the top there. But what you see is, notice the arrow. Notice they're getting bigger as you go across because your stimulus is getting bigger. So the arrow is representing the intensity of the stimulus. Bigger arrow, more stimulus. Also, because the stimulus is increasing, take a look at your amount of work being done by the muscle. That's going to be represented by the tension. So our work being done by the muscle is also increasing because you've got more motor units responding. So for example, if you have a subthreshold stimulus, there's not going to be any motor units responding. You're not going to get any work out of the muscle. With a threshold stimulus, you'll have like maybe one motor unit responding. You increase the stimulus, you're going to increase the number of motor unit responses. In a maximal stimulus, you've got all motor units responding. In a super maximal stimulus, remember you're not getting any more work done, so you still have all motor units responding. Now, TRPA versus tetanus, you need to know the definitions of these two words. So what is TRPA? If you take a look, you are repeatedly stimulating the muscle with a maximal stimulus. So the stimulus isn't changing. Take a look at the green arrows. But what I want you to notice is the muscle is allowing to come to complete relaxation with each stimulus. But if you notice, the stimulus strength is getting, or the muscle strength is increasing as you move along. So again, this is the same picture. It's just showing you a little bit more spread out so you can see it. Take a look at these orange arrows. That's representing the stimulus strength. You can see all the orange arrows are the same. You can also see the upswing. Well, that was supposed to be highlighter, sorry. So you've got the upswing of that, which is representing your contraction phase, and you've got your downward, which is your relaxation phase. Okay, and you can see that the relaxation phase is longer than the contraction phase, which is what we talked about back in Objective 1. So the other thing I want you to notice is we're allowing that muscle to come to complete relaxation before we stimulate it again. That's TRPA. Notice the amount of work being done by the muscle is increasing, which is interesting because we're not increasing the stimulus. They're all the same. So how is the muscle able to do more work? Think about it this way. Every time, remember, calcium is the key. So calcium is what's going on here. When the muscle is contracted, the sarcoplasmic reticulum is releasing calcium into the cytoplasm. When the muscle is relaxed, we're putting that calcium back into the sarcoplasmic reticulum. Well, it has to travel back. So while it's traveling back, getting away from the actin and going back into the sarcoplasmic reticulum, it's in the cytoplasm. When you stimulate it again, not all that calcium was able to actually get back into the sarcoplasmic reticulum. So you still have some left over. What's going on with the leftover calcium? Well, when you stimulate it again, it shows up. So if you were to, let's say, stimulate it the first time here, and just for the heck of it, we'll say, you released 10 calcium ions to stimulate it. 10 calcium ions came out of the sarcoplasmic reticulum, bound to the actin, caused the muscle contraction. Now, when you stimulate it again, you're still going to get those same 10 calcium ions floating out of the sarcoplasmic reticulum, but you still have a few of that original 10 that didn't make it back yet. They're still hanging out in the cytoplasm. So while you only released 10 out of the sarcoplasmic reticulum, you'll got maybe 12 or 13 hanging out in the cytoplasm. More calcium ions, more muscle contraction that's going to happen. So over time, with this leftover calcium that's still hanging out, it just causes the muscle to do more work. That's summation. That is TRPA, sorry. Okay, now tetanus. Tetanus is a little different because we are not allowing the muscle to come to complete relaxation before you stimulate it again. The stimulus is the same strength, it's not changing. If you notice in the first picture, though, it's called incomplete tetanus because you're allowing some relaxation, but not a lot. If you notice in the second image, you have complete tetanus, which means there is no relaxation between muscle contractions. So you're hitting it more frequently with a stimulus. So again, incomplete tetanus, you have some relaxation. Complete tetanus, no relaxation. So to compare the two, with tetanus, your stimulus is at maximal, but you're hitting it at a very high frequency to the point you either have some or no relaxation. With Trepe, your stimulus is still the same, it's still at maximal, but you're spacing out your stimuli. So you're not hitting it as frequently. It's a low frequency because you're actually allowing complete relaxation between the stimuli. Tetanus, the disease, this just talks about, you're going to learn more of this in microbiology. The tetanus ends up secreting toxins. The bacteria secrete toxins, which affect the nerves, causing them to stimulate these muscle contractions to the point that it could actually cause fractures and could, bones break. You could actually contract the muscle to the point bones break. And this is from, yes, stepping on a rusty nail. This is what can end up happening. Oh, and this was just some little fun facts. Okay, and that ends the discussion on motor units.